Ooh.
Okay, everyone. So we have about 66 people online, and we might have a few more people join in a moment. I just want to thank Mikhail and Stephen for taking the time to run this workshop, this open workshop on IOTA and IOTA implementation for smart buildings. I think it's quite interesting. We'll be discussing a roadmap for IOTA as well. I just want to very briefly and succinctly discuss that if you are interested in blockchain applications for construction, please join the mailing list on constructionblockchain.org. And then I'll keep you posted on the events we are running and the projects we have in relation to blockchain application and the construction sector. So all the information is there. I can very briefly share my screen. So here, the constructionblockchain.org, you have all the different themes that we explore. So the CBC is generally interested in blockchain applications in relation to construction from the perspective of legal applications, financing, culture, and change. This is mainly adoption. And we have more details here: design, construction, safety, building services, energy and sustainability, smart cities and social welfare, and policy and compliance. I would ask you to explore this. We are also publishing white papers and presenting this in the Parliament as evidence for the development of policy in the construction sector, of the use of blockchain in the construction sector. And this, of course, is related to smart contracts. And we have a number of events. So we have the IOTA workshop happening now, but also the second blockchain in construction research workshop online very soon. This is on the 15th of April. And then we have the CBC conference. This will be in October. So please subscribe, and we'll keep you updated with the things we are doing. And if you have any questions, contact me or contact Leo, and we'll get back to you. There are many ways to participate in all this, including getting involved with the technical projects, the technology open source projects that we'll be deploying very soon. So with no further ado, I believe Mikhail will be presenting briefly on the IOTA Foundation. And then after that, we start the workshop with Stephen. Thank you very much.
Thank you. Yeah, I will give a quick overview of the IOTA Foundation, the organization behind the IOTA protocol that will be discussed and present more in detail by Stephen later in his demonstration. Let me just quickly grab my slides, make use of them so it's easier to follow. Yeah, should see my screen now. Let's go full screen. Right, I didn't pick the right one. Okay, yeah. Thank you for joining. My name is Michele Lenati. I work with IOTA Foundation. I'm the head of the telco infrastructure development. Been working with Abel and Stephen since I think one of the first event last year as part of the CBC, as well also supporting Stephen in what you will see later demonstrated. The vision of IOTA is basically connecting people and machine using a decentralized protocol that is not requiring fee like we have seen in a blockchain and previous decentralized protocol. There is always the need for paying fees when you issue transaction toward a ledger. The mission of IOTA is to remove this fee, but maintain the same properties of security and also increase scalability of the protocol. The foundation has been established in 2017. It's registered in Germany as a not-for-profit organization. It's actually the first regulated foundation based in Europe that aim to develop a decentralized and distributed ledger technology. We work with different partners in academia, government, and business. You can see a list of them below. Some of them are also involved in this sector, and especially in the smart energy sector, like NG, as well as we work with a consortium of industrial standardization body like ICLAS, EONG. Next slide. The foundation is currently made of 110 people, employees from all over the world. So we are decentralized not only as a technology, but also as a organization itself. All people work since a long time remotely already, even much before than the pandemic kicked in. So we are covering 25 nationalities, but we share one vision. The vision is the one to create this distributed ledger protocol that help to connect people and things without fees. We are not only working as a foundation that develop technology, we are also trying to promote technology adoption in different domains, different sectors. One of these is now construction, that is part of a larger, let's say, scope of infrastructure development as well as smart energy. We continue to fuel research and innovation, and not only inside our own department, but in collaboration with the academic organization. And we are also issuing grants for them to support our work. And the same we do with the development of an ecosystem fund that help to support the IOTA ecosystem technology and company that want to develop on IOTA. Bit of history. In 2010, the founders of IOTA start to explore the current issue with the existing blockchain protocol, mainly related to scalability. In 2014, there was the first concept of the IOTA decentralized protocol based on decentralized distributed secret graph, DAG, which are the different data structure than the chain of block that you have seen in blockchains. In 2015, there was an initial raise of funding for developing further the protocol. It was not an ICO like you've seen, many promises and not much delivery. It was just a small crowd fund that was helping to launch the IOTA network. In 2017, finally, the foundation was established, and now we are in 2020, where we have a production-ready protocol that can support different and various use cases. As I said, our mission is to create this ledger that allow people to connect and share their data, as well digital assets, or establish their decentralized digital identity, empowering them to control who actually access their information and their data. Data must be secure and might be accessible on demand by access given by the rightful party. And we want to be able to provide a protocol that is easy to integrate even with a constrained device like Internet of Things device, to enable a machine-to-machine economy and communication based on this data. The IOTA technology, you see an example of the growing IOTA ledger. As you can see, it's not a chain of blocks that have to be mined and that are attached to the main block, but it's called a directly secret graph. And in particular, in our case, in our implementation, we call this the tangle. You can see it's quite entangled. That's the reason, because the way it builds transaction is basically transaction can append to previous transactions, not in the same place, not in the same block, but in different portion of the network. This allows to have two things. One thing is that you don't have this super user that you call miner that block a bit the scalability of the network and impose fees to the network. You can attach to many different points. All nodes have the same role in IOTA, and this guarantee much more scalable and distributed infrastructure where the many transactions can be processed in parallel. So as a result, we have, again, an immutable ledger for sharing data, not only data about monetary transaction, but also pure data that you want immutably stored in the ledger, which is still secure, as secure as the blockchain, other distributed ledger, but it's also highly scalable and low energy, has low energy requirement. Not having miners means that we don't need fees and incentivization for triggering this process. Next, that's allowed to create the main distinction between IOTA and other blockchain infrastructure, where you have basically fees that you have to incur in any kind of transaction that you issue, whether it's a value transaction, exchanging value between wallets, or is sending and storing data into the ledger. You always have fees. IOTA allowed to have a parallel infrastructure where both you can process value transaction, exchanging monetary value between wallets, but you can also send and store data into the ledger in parallel without incurring fees in any case. IOTA comes with a basic technology, which is the ledger. On top of that, we start to create a second and third layer protocol that include decentralized digital identity, secure data streams, access management, as well as smart contract that is not shown here. And then we have started to develop also a library that allow to use and connect to the ledger from different device, as well as provide different use case and different solution for that. So like certificate and audit trails. Few of the technology you will see later in the demonstration. I think Stephen will give more technical details. One of these is IOTA streams. Basically, IOTA stream is a second layer protocol that allow to create encrypted data streams on the Tangle. So it's similar to the concept of channel that you have seen in other ledger. This is particularly suitable for sharing time series data that, for instance, come from one source. It can be a sensor, so and attach all of them in the same in different position of the ledger, but all linked together. So for reading them, you just need to know where the first of this transaction, the data transaction, is stored, and then you can subsequently read the other. You can never go backwards, so this allows to create also some sort of access control on top of the fact that data are also encrypted. This guarantee actually that data are managed by the source and sovereign by the source of the data itself. Other than IOTA stream, we have IOTA access. IOTA access is basically an access control management protocol that basically use the ledger and both of the capability that the ledger offer for two functionality. Basically, it's defining policy on which device can be used and trigger this policy and access to the device only if a payment is performed between the wallet that one is the wallet that the device is being used, one is the wallet of the device that requests access. Third protocol is IOTA identities. I don't know how familiar you are with the decentralized digital identities, but IOTA has implemented its own version, but based on a standard like W3C standard for decentralized identity documents and verifiable credential in order to create a set of primitives that allow to manage a self-sovereign identity. So basically, identity in the form of public key and a document, the ID document describing this public key and then points for verifying ownership of this public key can be self-sovereign created by the owner of the identity on the ledger. And to this can be used this infrastructure to attach a set of signed verifiable credential that express attributes of this identity. So this allows to really create a decentralized identity ecosystem where identities and attributes and their access is managed by the owner of the identity, and the verification can happen thanks to the information that are securely and immutably stored into the ledger in a decentralized way without requiring any end-to-end integration with the centralized identity management system that create honeypot for attacker because all the information are there, and create also single point of failure in case of denial of service attack, among the other. IOTA recently just added to the protocol the possibility to create tokenized asset. We are now exploring the possibility to create, and we have requests for comments for a protocol to create both colored tokens that can be used together with IOTA token but without the volatility associated to the token in supporting and fueling some kind of incentive mechanism for any app developer and apps, and as well creation of non-fungible token that you are very familiar with. IOTA is also smart contracts. We are launching now the alpha phase. We just released the alpha release of smart contract and progressing in their development. So IOTA smart contracts are second layer smart contracts. So this means that are not embedded in each node. So this does mean that when you want to run an IOTA smart contract, you don't need to run this in all the nodes, creating a scalability issue and request for fees, high fees like you have seen in Ethereum smart contract, but the contract run on a second layer. So there is only a dedicated set of nodes that can be selected that is called committee that will run the IOTA smart contract, the protocol, and all of them will come with an output that will be using input from the ledger. It is immutable and will write output in the ledger, and everybody will sign this until it's not reached a quorum of how many, and this is a parameter can be set, how many of these nodes in the committee have agreed to the same outcome of the smart contract. So this brings smart contract is much more efficient, much more scalable. You can see a network running, a IOTA network running many smart contracts in parallel, not only one at a time, and without need for fees or very limited fees, just incentivize the work of some of these nodes in the committee, but they are not bound to the value of the token and the volatility of the token like you will see in gas and the Ethereum token in the Ethereum network. Very quickly, as I mentioned before, IOTA will work with many standardization activities. We've been working with the TM forum in the telco infrastructure development side. We work with the OMG to standardize the use of the ledger, the interface, the API that we provide for our main ledger and other protocol. In the context of smart city, we work with the Fireware Foundation that provide many technology for smart cities and Internet of Things device. And we are also active in the Linux Foundation. As I said, we cover different domain. Our main activities now, it's in the mobility automotive sector and global trade and supply chain sector. Then we have other activities in different domain that we are now trying to boost our presence in. Few quick example, but you will see more and more detail use of IOTA with Stephen later. We have done work with the Jaguar Land Rover in the past to create a car wallet that allow people that drive a car to monetize the value of their data, the data the car generates. So this data can be stored in IOTA streams like you have seen before, and this remain private to the owner of the car. Access can be given only after the payment to the car wallet is performed. So you can imagine a scenario where data can be crowdsourced from car running in driving in a given city district. So from a district manager, from a city manager that want to know the status of the roads or things like this. This data can be crowdsourced, but crowdsourced in a way that the owner of the data control who access the data, and that's the possibility to monetize the data. This is the real link between IoT, connected machine, and machine economy that IOTA can enable. So you can see in this use case. Another scenario that you will see later, it's about creating positive energy district. It's how to enable buildings that actually not only consume energy, but also produce energy with new renewable technology source like solar panel that can cover the whole facade of a building, how they can generate and sell this excess on peer-to-peer market. So this needs to connect the device generating, need to connect the building, need to know what kind of energy amount can be sold to the marketplace, and need to collect payments directly at device level, at solar panel level. So this again is something that IOTA can enable. You will see this in much more detail with Steven. Something similar we have done as well. It's some work with the climate kick. So the idea is that actually you can create, and that can be relevant to construction and blockchain topics. You can create digital twin of buildings that allow to basically understand how efficient is a building, to rank the building efficiency in terms of energy consumption in a way that is actually auditable and immutable from the source, because data can come from the building that produces this digital twin can directly go into the ledger and remain there, immutable and also auditable for future use. And that's pretty much. I think it was quite of a rush, but I want to give Stephen as well the opportunity to deep dive now into how the technology has been used, not only what the technology is about. So if you have some question, probably we can take at the end of the Stephen session, I guess, I would say. And that was me. Yeah.
We can, I mean,
you can reach
yeah,
by
I think
mail as well.
People can ask questions now, I think, Michele, if that's okay with you, just while it's maybe fresh in people's minds. There was a lot of content there, so I'm happy to allow any questions. If there's anyone out there who has any comments, questions for Michele. And if not, I can get started.
Do we know if people can unmute themselves? I'm just wondering if people can either raise their hand or they can put in the chat if they want to ask a question, and we might be able to unmute them.
Okay. Yes, I'm not sure. Good point. I'm not sure how it's been set up. We have a hand raised. Abel is raising his hand.
Just testing, but a quick question.
Yeah.
Michael, it's I'm very curious about the relationship of IOTA Foundation and Hyperledger and what's going on there. What is the plan, basically?
Mm-hmm. I don't know if I mentioned Hyperledger. So there is no what we have done so far. There was an implementation of a gateway, IOTA Hyperledger gateway, and that was done independently. Of course, Hyperledger at the moment it's something that we keep an eye on. There have been there is some work in East Africa that I didn't mention before, so where the ledger, IOTA ledger is being used by the Trademark East Africa organization. That is an organization that helps to, let's say, promote the development in East Africa, whether it's in terms of technology or in terms of general infrastructure. And there we are using the ledger to simplify the process of exporting goods from East Africa, in particular from Kenya in this case. And that is very similar to something that also Hyperledger provide in the let's say flavor of IBM TradeLens project. So there is some kind of activity now going on where both ledger will be analyzed in terms of interoperability, how they can satisfy the same needs. So that's one work that's somehow linked to that. As well, of course, Hyperledger and especially Hyperledger Aries is very much devoted activities around identity and decentralized identities. Of course, when now with the maturity of the ledger and the IOTA identities going forward, there will be much more interrelation and things we will explore together with Hyperledger and all these sort of activities in terms of identities. That's, let's say, from a strategic point of view. From let's say a more technological point of view, the main difference that Hyperledger is a permissioned network. And of course, whenever you want to deploy an Hyperledger-based network, you have to first set up the nodes and the consortium that is behind who is running the nodes. IOTA comes as a main technology, as a permissionless network. The main IOTA network, the main net is permissionless. Everybody can run an IOTA node. And eventually, you can also have a flavor of private network. You can decide this and do this in a permissioned environment. So these are the main, let's say, technology difference between the two. Of course, Hyperledger is blockchain-based, IOTA is DAG-based, decentralized cyclic graph. So these are the few things. But definitely, yes, in the future, as also our technology mature and the different interrelation, especially in different use case and domain, there will be the need to explore more interoperability, of course, with other ledger. One of those is Hyperledger.
So thank you. Thanks.
Okay.
Okay, we have a question in the chat from Ben. Can you read that, Michele?
Yeah, when the smart contract will be available and what will be the programming language. Okay, I'm not 100%. I'm up to date with this one. I think we are in the alpha release now. I think there will be further release, I think, next quarter, if I'm not wrong. And definitely the language, we are looking toward interoperable smart contract. So, and we are aiming to support different set of languages and the smart contract, and virtual machine. So including the Ethereum virtual machine. So the smart contract might come also in language that you are already familiar. So for now, I think for the current implementation, we're using WASM machine and language. But in future, yes, there will be more interoperability and compatibility with existing programming language. I would say Solidity as well. And yeah, no, I don't think yeah, I'm not 100% sure I'm up to date with this one collaboration with Bosch and Fetch. Yeah, I've seen this news as well, but I'm not 100% sure about the aim of this cooperation at the moment. If it's directly the foundation or somebody using the technology, because as I said, technology is open source and can be used by our ecosystem and can be used by everybody anyway.
Awesome. I think now then, Mikhail, thank you very much for presenting. And I think, Stephen, if you're ready, I think perhaps we start.
Yeah, absolutely. Yeah, let me just get set up and we can get started. So just a big thank you to everyone again for attending. We've got 82 people online, which is really, really great to see. So before I give a quick introduction of myself, I wanted to sort of remind the participants, hopefully you read in the invite that there are a number of prerequisites required to complete if you want to follow along with trying to set up the energy grid, which we're going to go through for the rest of the session. If you want to set that up on your own local machine, particularly if you've got a bit of coding experience, then we'd really encourage people to do that and to follow along. So I'm going to, if you haven't had an opportunity to do so, then I've just posted the link in the chat where you should find the prerequisites. And you may have chance while I'm kind of doing my intros and getting the overview of the energy grid, explaining the concepts and things like that, you may have an opportunity in the background to sort of catch up and get those prerequisites installed. If you don't want to do that and you just want to sort of follow me, then I think you'll get a lot of value out of the workshop anyway. So it's not a prerogative that you have to do the install locally. The other thing to point out is that we're recording the session, and all of the key steps to getting it set up, I'll be posting the links within the chat. So if you haven't had a chance to do it during the session, or you want to go back and try to get it installed after the session, then you'll have an opportunity to do that. The thing that you really need to be aware of, though, is that if you want to follow on at a later date, you're really going to have to pull the code base from GitHub during this session, because it's not a public code base usually. So as part of this session, IOTA have kindly opened it up for the attendees, but they're going to remove access to it after the session. So the two things I think you really need to get installed if you haven't got done, and I put the link in there. One is to have Visual Studio Code installed. It's a free install for sort of Windows or Mac. And then secondly is to install Git. We're going to use Git through the command line to pull the IOTA repository. So if that's the most you can get done in terms of the prerequisites, then I'd encourage you just to do those two steps, and at least then you should be able to go back at a later stage and complete the exercise with the local install. Okay, so in terms of who I am, I'll just post my LinkedIn profile in the chat as well. So my name's Stephen. I've worked within the built environment sector for 22 years now as an innovation and technology consultant. And so, my job is quite exciting. Usually I'm the guy that gets to sort of test out and implement all of the latest cutting edge technologies. I spend a lot of time sort of learning, researching technologies and thinking about how we can use them to solve business problems. I don't consider myself to be a coder or an engineer, but sort of a super user. I very much like to get software installed and to sort of tinker and play with the technologies, because I think that's the only way to really truly understand how they work. So it's the same approach that I've been taking since working with blockchain since 2016. I've been involved with the CBC for a number of years. Abel and I have worked on some projects together. We did a project, for example, with Autodesk, where we connected the Ethereum blockchain to the back end of the Forge in Autodesk, so that when you were reviewing a model, you could tag comments to the model, and those comments and the responses would be registered on the blockchain, on the immutable Ethereum blockchain. And then I've also been doing quite a number of projects. Input volume of your mic. So let me see. 1 second. It's coming through quite loud, is it?
Yeah, it's distorting a little bit. Sorry, Stephen. Just for the recording.
Yeah, it's
40% maybe or something.
Yeah, but it sounds quite clear.
Quite clear.
Just the occasional, yeah, but it sounds quite good.
Is it better now?
No,
Yeah,
both are good in my opinion. I think with the headset, we pick up more your voice without the echo. So I think it's fine.
Can you still hear me now?
Yeah.
Yeah, that's great. Thanks, Stephen.
Sorry, 1 second.
Let me know.
Say that again.
Say that.
Can you hear me, Leo?
Yeah, that's perfect. Thanks.
Yeah, that's good.
Very much.
Okay, perfect. Sorry, I had my computer on. Yeah, I think maybe it's going to be less loud if I just do it through my laptop. So let's go with this for now. Yeah, so I was just saying that I've done some projects with the CBC, and I've also been working with Michele with IOTA. I think you give a very good introduction to IOTA. It's I think it's a very interesting distributed ledger technology because of the way they're trying to build out this feeless infrastructure. I think a lot of you, if you're aware of blockchain advancements, one of the challenges that the big players like Ethereum and Bitcoin have is that the costs of transactions are pretty high. And there's also, of course, an overhead in terms of the proof of work. And some different approaches are coming out in terms of how to secure and validate these networks without using proof of work. But the IOTA platform, I think, which has this vision around feeless, is very interesting for the built environment space that I'm interested in. So this idea of being able to have a sort of machine-to-machine economy where sensors and smart devices could potentially could host a node and hold their own wallet, and they can transmit both data and also transmit value fees, as you saw in the slides there. I think it opens up some really fascinating use cases, and I think it's going to be some form of blockchain type infrastructure that allows this value to be transmitted will be really an important part of the rollout of the Internet of Things, which of course is gaining tremendous speed and growth already. But I think it's a piece of the infrastructure that's really going to help with the rollout and with security and data privacy and data protection of the Internet of Things devices. So what we're going to do really for the main session is to get hands-on with installing a project which I didn't write this project, so I'm not going to take any credit for it. In fact, what I'll do is I'll start sharing my screen at this point so we can walk through. But I'm sharing the link there to the GitHub within the chat. And let me share if I share this desktop. Okay, and hold on. I'll just move this across. So hopefully you can see my web browser now.
Yep. Yes.
Correct. Okay, perfect. Where did the chat go? Okay, so let me. So the code base is that we're going to install is located on GitHub, and so we're going to take a local copy of this. So we're going to clone this GitHub repository, and we're going to do that through a command line. And I'm going to walk you through the sort of main components of the repository to explain how it works. And you'll see here the link down here is that this is the documentation that goes along with the repository. So as it says here, this is it's a implementation of a peer-to-peer energy grid, which the IOTA Foundation have developed as a demonstrator of the types of ways in which the Tangle and some of the second layer technologies that was mentioned by Michele, how they can be used also. So I'll firstly sort of walk you through an overview of what the peer-to-peer energy grid is, and then once, because that'll give you a good grounding in understanding the concepts, and hopefully will make the review of the code more meaningful. And then we'll go through the steps of installing the code, and then finally we'll be able to see the energy grid running locally on my machine. Hopefully, if you're able to follow, you'll be able to get it running on your own machines also. And then we can sort of actually see the grid running and see the interactions taking place on the grid between the different entities.
Hi, Stephen. Sorry to interrupt. So I think we're getting a 404 on the GitHub link. I wonder if it's a permissions thing, perhaps.
I think there was the password and the username, right? We create for this.
Okay. Well, I think if the
You want me to share here in the chat?
Yeah, this link here that I'm showing.
Yeah, that's the one.
Yeah, no, but the username and password, I guess.
Okay. Yeah, I'm going to share the username and password when we get to the stage of installing it. So
Okay, yeah.
yeah. So thanks for pointing that out. Yeah, you're quite right, because I'm unbeknownst to me, I'm logged in. I didn't realize this myself, so I can see it. But yeah, everybody will soon be able to get access to this link. And we're going to take you through the step of actually installing it locally. We'll be looking through this in some detail. So yeah, so the energy grid it's the intention of it is to create a peer-to-peer energy grid with IOTA Tangle as the sort of transport layer for transmitting information on the energy that's being both produced and consumed by energy consumers. And it's also allowing for the transfer of fees in the form of IOTA tokens, so that consumers can pay the energy producers for the energy that they're supplying into the grid. So the business case here is that it's going to be taking away the need for there to be a centralized energy company that's setting the pricing for the excess energy that's surplus energy on the grid. What this demonstrator allows for is for the producers to set a price for the energy that they're providing to the grid, and then there's various calculations that can take place by the grid itself, which would pair up a consumer with a producer, and the process of automating the transfer and the payment is all done through code. So there's no intermediary that's involved once you have the grid up and running and you've authenticated the entities to the grid. So the roles that take place on the grid are fairly straightforward. You have your consumers who are using the energy being supplied. You have your producers. The producers each can have a number of energy sources which are providing that energy. So it could be solar, wind, geothermal, etc. And what the producer does is they aggregate all of the energy levels that are being produced, and they also set the pricing. and they then sort of provide that information into the grid, and then the consumers are connecting into the grid to advertise the energy they're spending and provide details of the wallet that they will use to pay for that energy. Okay, so what I'm going to do, we're going to go to the next page and we can look at it in a little bit more detail in terms of understanding the architecture of how the platform works. So I'm going to skip over this diagram. There's a couple of different ways of looking at the relationships between the entities in the system. I think this way is quite easy to understand. So we're looking at the same 4 entities that are participating. If we first of all start off from the source on the left-hand side here, as I explained, the sources register with a particular producer. So there's a registration process that takes place at the start before they start to transmit their energy production into the grid. And similarly, on the right-hand side, a consumer would register into the grid on this side. And then there's a registration process for the producer to register to the grid as well. So these are all sort of setup steps that happen before the transfer of data and fees take place on the network. So, and the way that the data is actually transferred is done through one of these second layer protocols. So Michele in his slide, he talked about this second layer protocol called streams, and effectively it sets up a channel between participants, which you can invite people to be able to connect into that channel, and they would see the data that's flowing. So I like to think of it as like, if you're thinking of Twitter, you could post a tweet on the network and anybody can read it, but you can also send a tweet to an individual, and in that case it's still being passed over the same network, but it's in effect hidden from all participants. So the source sets up a channel which is basically just sending a constant stream of the kilowatts per hour that it's producing at each time slice, and then you have a channel which the producer is consuming that information from each of the sources, so multiple sources, and then there's a channel which is between the producer and the grid, where they aggregate those sources into a time slice to give a total amount of energy that producer is providing into the grid. And they also provide the information about the price they want to set for that energy, and they're providing the payment address which the consumer should pay the money to when they consume the energy. And then on the other side, it works the same way. So you'll see here that we have multiple different of these channels being used. They're all being used for different purposes. The consumer, of course, is just constantly updating the grid with the energy that it's being used, and providing they'll provide the wallet that they're using to make payments. And then finally, the grid, it's consuming all of the consumer channel data, and it consumes the MAM channel that's coming from the producer, and the calculations are done to pair up the production with the consumption. The grid takes a fee for undertaking its role from the consumer, and then the excess is paid to the producer. So there's effectively 2 transfers of fees that take place. So that's really an overview, and at the bottom here it's showing that that's all being done as a second layer protocol on top of the Tangle. I think, as Michele explained, the nature of these channels are such that it's effectively hidden from anyone who's listening in. It uses what's known as a whisper protocol. Anyone who's listening in to the Tangle wouldn't be able to see any of this data being transmitted. It can also be encrypted. So if somebody did get access to the keys to be able to view the channel, they could be encrypted unless they have the private key to encrypt the data as well. Yeah, so that's an overview. If anybody's got any questions on that, it might be a good time for me to just quickly take a second and pause. Trying to see if I can see the chat. Show chat. Okay. Yeah, so feel free to raise it. I'll try and keep an eye on, I've got the chat up on the side here, so if anybody has questions as we go. Yeah, so would the grid in this case be National Grid? Yeah, I mean, it could be, I guess it could be any grid really. Potentially this type of network could be used for like a localized grid. So it could potentially be some sort of energy grid, energy provider that's taking place maybe in a sort of third world country or a less developed country. But effectively, yeah, it could be running in parallel with any type of grid. So that's an overview of the sort of architecture of the application. What we'll quickly do is take a look over so the actual data that gets transmitted in the MAM channels. So you'll see here from the source, which is of course, maybe it's a hydroelectric or probably more likely to be a sort of solar panel. Perhaps somebody's got excess solar panel energy that they want to provide to a grid for resale. So you'll see it's very simple. You really just have the start and end time, so a time slice, and then the output in kilowatts per hour, which is being made available. And then the channel has this concept of needing to validate that the channel is being sort of opened, and they just do that with a hello, and then when the channel's been closed, it has a goodbye. So this sort of signifies that the channel is open and then shut down. So these channels can be started up and shut down sort of on the fly, which is quite a sort of an efficient way of doing this. They only really need to exist and be stored on the Tangle for the time which they're being used. And then from the consumers, just to show you this in a little bit more detail, the source. So they initialize their MAM channel for its time slice, which is advertising the power output as I explained. They're registering with the producer. They receive that acknowledgement, and then throughout the time which the source is running, and this is one thing to note, is that the producer's reading the MAM channel that's been set up by the source. So the producer's effectively just listening in at all of the updated output data that the source is generating. And this will just continue to happen until that source is updated. So perhaps it changes its information, or ultimately it's deregistered, in which case it would cease to provide data into the grid. So similarly, the consumer, it's very simple. Again, very small packets of data being sent here, time slice, and then the amount of data the consumer is using. And similarly, again, you have the consumer creating their channel, advertising the power usage per time slice, and then the grid is creating a channel in the opposite direction for each of the consumers. And then you have the same process of a registration taking place. As the grid, as it's running, the consumer's reading to find out how much it owes the channel to facilitate the payments. And then the grid is reading from the consumer's MAM channel to calculate how much it owes. So there's this two-way process taking place, both how much is owed, and then the consumer's reading how much it owes to facilitate the payments. Okay, and the producer is similarly time sliced, total amount of aggregated output of all of the sources that the producer has had registered against it. And then here you see it's setting a producer price in IOTA tokens per kilowatt hour, and then it provides its payment address. So this is all that's needed for the application to be able to facilitate the payment by the grid. And what it says here is that the price isn't guaranteed to be met, and the grid may calculate its own price by monitoring and recording the prices from all producers. So there is some intelligence that sits within the grid to actually facilitate the transfer of and matching between the producers and the consumers. Okay, so I think we've sort of seen the same principle exist with the MAM channel for the producers, and I think that's everything that is really worth looking at. So there's just more examples on this page. When you have a chance to sort of look through, it gives you some of the more details about the information and data being transmitted across. So does that, hopefully that's given everyone an understanding of what the, the participants involved in the grid and sort of how the transfer of both data, which is really kilowatts per hour, and the transfer of the tokens takes place. So what I'll do now is we're gonna jump into Visual Studio Code, and we're going to clone this this repository here so that we can get it running on our local machines, and then I'll take you through looking at some of the code in a bit of detail as we start to install it. So let me apologies why I throw this across. Confused as to which screen you can see. I think you can see Visual Studio Code now on being shared. Is that correct?
Yeah, that's good.
Perfect. Okay, so I've just got some instructions here as well, which I'll okay, so yeah, if you want to follow on along with your own local install, on the left-hand side, I'm going to sort of install everything from scratch. I've already got a version of the Energy Grid running and installed on the right. I'm just going to refer to it to read the instructions as I go. So if everybody wants to, what we need to do is just if you go and open a new folder, which can be any location on your local machine. So I'm just going to create a new folder in a directory I keep called code, and just open up that folder in Visual Studio Code. So, and then if you go and start up a new terminal session, so you should be able to go into the menu to terminal, click on new terminal, and it might appear in a slightly different place in your setup, but it should open up a terminal session to allow you to do the command line request to clone the repository. And so just to make sure you're in the folder that you want to install the repository in, and then we're going to get going with doing some coding. So okay, so this is I will post. I've got that right. I'm not copying the whole thing. Easy for me to post. I'll post this into the chat. here. And so this is the stage, going back to the comment earlier about how you're going to get access to the repository. If you paste and run this command within the terminal, it's logging you in as a user called IOTA-P2P at github.com. Now, it should ask you all for a password. It didn't for me because I've installed it previously. So when it asks for the password, you can, sorry, Leo's just told me I'm not sending this to everyone. I'll try again. Okay, so everybody should see that. So again, if you paste that into your terminal, providing you have Git installed, it should start to run that request and ask for the password. And this is the password you need to type in. So if you go ahead and do that, what should happen then is that you should see a full copy of the repository that we saw when we were looking at it on the browser. I won't jump back. So I'll sort of briefly explain this repository a little bit. So the way that the repo is organized is that you have a folder called common. Let me just, before I stay here, if you try to log in, it will send. Is that right? Okay. Do you want to take a look at that, Michele? I'm not sure if you can see the comment in the chat. They're saying that when you try to log into the repository, it's going to send a 6-digit verification code to the user. So I think that would be a problem if there's.
Okay, yeah, let me check.
Because if that second factor could be removed, then I guess people would be able to learn it without needing to bother whoever that message is going to.
Okay, yeah, I'll try to have a look quickly. Yeah.
Okay, all right. Well, let me know if you get around that. Okay, so we can step back and run that install again if Michele gets that resolved. So in terms of the structure of the repo, we've got a common folder where if I filter down into the search, you'll see here that there's a lot of, basically this is where all the code for all of the sort of main sort of programming code for the energy grid is stored. So we have all the information, all of the code that runs the registration process, the API for managing sort of wallets and storage. We're going to go into the detail of what all this is shortly. It sort of has the code in here which talks about how consumers and producers are managed. There are strategies in here which define, so if I click into the consumer strategy, for example, it defines when you set up a default consumer, it's because we're not connecting in a real consumer, which is publishing real consumption data. It's for the demonstration, it creates a sort of dummy consumer who is either producing a sort of random amount of energy production for a time interval, or you can set it up with a fixed level, which you can set once you go in. Once we've got the energy grid up and running, you'll see the process of setting up a consumer and having them either publish a fixed amount or a random variable amount of consumption data. And then similarly, how the producers work, how they how they pull together the different aggregated levels of energy production from the sources is sort of defined within this, this default producer strategy here. So really all of the heavy lifting code is done within the source folder. And so what we're going to need to do is we're actually going to run, before I show the demo just quickly, the standalone is the code exists in here. If you wanted to use this code to sort of set up your own application, which didn't have the front end, which we're going to be using, then you can set up the producers, the sources, the grid, and the consumers using the standalone code, which is we're not going to go into there today. What we're going to do is install the demo itself. So the demo will call on a lot of the code from the common area that I just explained, and then there are two parts to it, which is quite common for a sort of Node.js application. We've got the client, which is the front end, and so that's really the user interface that you see, and you'll be able to see the production and consumption levels and the different participants involved in the grid through the web interface. And then the API is which deals with all of the connectivity to the back. So that's really the back end of the application, and deals with the wallets, the connection to the blockchain, etc. So there's really two parts of the demo. So we'll get started on installing. First of all, as I said, you need to install the common libraries. So if you change directory to go to the peer-to-peer energy folder, which of course is the one we just pulled from GitHub. And
yeah, I've shared a few PIN numbers that we got.
okay.
It's a bit of an issue now, a challenge, because we set up this unique account to make it easier.
Yeah.
And we are receiving different requests, so somebody has to try. One of those will work probably. So yeah, please try, and if there are more requests coming in and more pin generated, I will share. It's a bit of clunky, but that's the only way we could do it now.
Okay, perfect. Would it be fair to say that, yeah, if anybody is particularly interested in getting installed locally and they don't manage to today, then they could reach out to the IOTA Foundation separately to get?
Yeah, for sure. My email is
Yep.
in the slide, but yeah, we can share after.
Okay, perfect. So yeah, we're going to first install the common directory. So if we change directory to common, and then we're going to run npm install. So this is using Node Package Manager. So what this will do, if people are not familiar, is that you'll see here within common, when we click npm install, what it'll do is it will it adds this new directory here called node modules, and effectively this is pulling all of the dependencies which this application needs to run. So we have all sorts of shared core sort of coding directories here, which are required to be run, including the core node directories that have been, or node modules that have been created by IOTA themselves. So a lot of the work that is being, a lot of the heavy lifting is being done through us, calling upon the code that exists in here within IOTA, such as this is the JavaScript libraries which are used for management of those streams, the second layer protocol streams that we talked about. And then there are various other directories to do with with managing, how, for example, how IOTA deals with bundling up a number of transactions into sort of an equivalent of a block. So all of these modules have now been installed. I'm getting a few errors, but it hasn't caused a problem with me previously, so we can ignore those errors for now. We're now going to change directory, and we've got the common. So I need to just run a build inside the common folder first. So there's a few sort of build steps that were created within the code base. So things that need to be executed in advance and compiled. So you should get a response back from the command line to show that those builds have been completed without errors. And so the common directory is now installed. We can now jump over to the API. So we're going to install the API first. So same as before, we'll install. So you can see this running again. We don't have a node modules folder in here yet. So if we install, do npm install, it will pull those node modules. You'll see them coming across there. And they're all now installed. So here's where the installation gets a little bit more interesting. What we need to do next is that we need to create the IOTA wallet that's going to be used by the grid. So this is where the tokens will be sent and managed by the grid. As I understand it, when you create a consumer and you create the producers, which we'll do once we're into the interface, it automatically creates the wallets that are used for those accounts. So it's the grid wallet that we're needing to set up sort of manually as we go through the install. I think it's an interesting exercise because it gives you an opportunity to understand IOTA a little bit more as to how it works. There's a link here, which I'll post in the chat. Now, IOTA are only sharing the steps for creating. What you need to do is create a wallet seed. So this is really just it's an 81 letter, I think it's hexadecimal, probably, seed, which is your sort of unique key for your seed, and then you can then use that seed. So that's just really a randomly generated number, and then with that seed you can use it to then create a unique wallet seed, and it's the wallet address rather, and it's the wallet address which you can then send tokens to and from. So
I think that one, to be precise, is still in tries, I guess. It's a bit more than hexadecimal. Yeah. So
it's tries. Okay.
Yeah, tries. Yeah, something that from the previous implementation.
Okay, perfect.
Carry
Thank you.
forward, but yeah, no, just out of curiosity, I would say more than.
No, that's good. So here's the command which you can run on Mac is as such. So I'll copy that into the chat also if people are following along on Mac. What I've also done is I created a bunch of just random seeds before. So if you're on Windows and you don't have the opportunity to create one, see. Just try and copy them across. So you can select one of these. It's perhaps not letting me copy so much data. Yeah, so I'll copy a few of these in. I don't think it should be a problem if people use the same ones. So you'll see that you can see where they start and end at 81 digits. So I'll just copy a few more in. So you should be able to, if you just make a note, if you just sort of copy and paste one of these seeds, just pick the one that you want to use, because we're going to use it very shortly. So once you've got that, the wallet seed, then we use that seed to generate the wallet address. So if you go into the code under API and it's under source, located in demo API. Sorry, 1 second. Demo API. Okay, sorry, it's just, yeah, it's sat here under API, and then you see there'll be a file here called generate address. So all we need to do is to copy the seed that you're using and to paste it into this bit of code here. So what this small application is doing is it's firstly, it's an important point to mention is that we're running this application on the development network for the Tangle. So, of course, the Tangle is running in production, and it facilitates the transfer of data and value for real IOTA tokens, and they hold value in the real world. They sort of hold a value against dollars or pounds. We'll be running it on the development network, and what we'll be able to do in the next step is to request some free tokens from a faucet. And so firstly, this is connecting us to the development Tangle, and with the random seed that we've got here. Oh, sorry, someone's pointing out. Yeah, thank you. Oh, that's good. I'd accidentally not copied. So yeah, just copy the full 81 digits like I've just shown here. And then that's the only change that's needed. You can save the changes to it, sort of Command or Control S, or you can click this button up here. And then all we need to do is to run this particular JavaScript file. So I believe we just run, we just run this command here. It's running the node command, which is just node and then the name of the file. We're already in the correct directory, so it's sat under API. So it should find this file and then execute the JavaScript. So I'll run that, and then here it gives us our wallet address. So this is the address that we're now going to receive some free tokens into. So I'll copy and paste the link to the faucet where you can obtain the tokens. So I'll just let me just bring my second. Excuse my jumping around. Okay, so I think you can see my my desktop now. So my browser. And yeah, so this faucet allows us to enter the address that we just generated, and then request some tokens. Okay. So I'm just going to copy the address and paste it in and request tokens. So this takes a few seconds to process on the Tangle. If we go and check click on the button that says check balance here. You'll see that it's registered the request on the network. Sorry, it's taken us to the address, which is the address we generated, but currently you don't see any transactions that are shown as being executed. And if we give it a second, we'll see the transaction executed. Okay. Excuse me, I'm just see where you went. Let me just move this to my other window for now. Apologies. Okay. Okay. Yeah. Can you confirm? Can you still see my browser?
Yeah, that's all good.
Perfect. Okay. Thanks, Leah. So now you can see here that we've got a confirmed transaction here against this wallet address. So we've received yeah. So 1,000 of the I can't recall what the IOTA guys call the different denominations of the token, but we effectively got one IOTA token, which breaks down into 1,000. So in the application, we'll be trying.
Yeah, it's MyIOTA.
MyIOTA. Yeah. So we're dealing with MyIOTA denominations in the application. So we know now that we've got some tokens there which we can use once the network is up and running. So I've lost my it's this one. Okay, cool. Okay, so hopefully some of you have been able to get to this stage on your own as well. So we've got the tokens. What we now need to do is to create a configuration file which makes use of the wallet address we've created. And so when we start the network up, it's kind of using using our own wallet. What this is also, let me just go into it and then I'll start to explain it in a bit more detail. So if you navigate we're in the API still, but if you go into the source folder and data, you'll see here there's a configuration file here. So we're going to have to add the nodes. We saw this once before. This is going to be the IOTA dev network nodes, so that this is what the transactions are going to take place over, through those nodes onto the Tangle for the development network. And then we also need to input the details. This was part of the prerequisites. We had to create a DynamoDB and an S3 database and bucket, so that because some of what IOTA is doing here is that they're registering some of the data of the transactions that are taking place. It's being pushed to a regular centralized database as a backup, so that you can take a look at the data, in sort of Amazon Web Services, as well as being able to query it on the Tangle. So what I'll do is I'm going to copy and paste this template here, and we're going to rename it, and we have to call it config.local.json, and then I'm just going to use the version that I've got running already. So I'm going to paste oh, sorry, I'm looking at the wrong. Give me 1 second, because there's 2 config files that we're needing to modify. Yeah. API source data config. Yeah. Okay. So this is the one we need to use. So I'm going to copy the details for the node that we're using in here, and let me just copy that into the chat. So it can be placed in there. I'll just go back so you can see. So it goes into that section there, and then you would need to insert your details for the. So you've got the region, the key, and the secret access key. So all of this is explained in the prerequisites documentation, so which I provided the link for at the start of this session. So if you go back, if you haven't done this before, then you'll certainly be able to go back and populate this at a later date with this information that you get from Amazon Web Services. And then finally, we're using the wallet address that we just populated. Sorry, the wallet seed, which is what we used to create the address. So it's the seed that needs to be populated into there. So that's the configuration done. So again, we're in the API, so this is going to facilitate the connection with the Tangle via the dev network. It's facilitating the connection to Amazon Web Services databases for the backup of the transaction data, and it's also storing our wallet seed. So out of the way. So now what we can do is we can run back into the terminal. We can now do an npm run build. If you recall, we'd done an install of the API. Now we've done these configuration changes. We now run the build, and it's going to call upon that config local file that we just created in performing the build. So that just takes a second to execute. Okay, so with that built, we can now actually start to look at some of the results of what we've been doing. So we can, if you now go to, I just got that. If we now go to the web browser and go to the, basically the API is, let's see, hold on. Sorry, I have to start it. So once we've built, we've done the pre-build, we just need to actually start the API so that it's running. And when it's running, it started it gets started on, and it tells you up here on server port 4000. So if you were to go to localhost 4000, it's coming up now. You can see that the API is returning a confirmation that it's up and running and the version it's running at. What you now need to do is to initiate the API. So I'm just going to click that. It takes a few seconds to run. What this is doing is it's running the code to connect, to check the connections with the DynamoDB and the S3 database. And it's going to create the tables that are needed so that once the grid is up and running, it knows where to populate the data, which tables to populate them into. And it does other checks to sort of check your, to check the DevNet details that you put into the configuration. So in a second, this should return a response to say that it's been initiated. So you should see with the response that you get, if it's the first time you've run it, you'll just get a confirmation to say initiated successfully. You'll see here that it's telling me that I already have the bucket and the tables already created because I've run them before. But providing you don't get any errors here, I think you're okay to proceed. So now we've got the API running. We've installed all the common libraries, and so this API is now going to continue to run. So what we need to do is to open up a second terminal window. So you could either go through the menu at the top, new terminal, or you can just click on this plus button. And we're now just going to do the final step, which is to configure and install the client, the front end. So we're going to first change directory and into, sorry if I list. Okay, I need to just default into the, I've been thrown out. Back into the right directory. Okay, and then CD. So we're going to go into the client of the demo, and we're going to run an npm install again on the client, and this will be installing the node modules required by the client. So the only step, there's been a few things that we needed to do to configure this, but essentially it's just been a process of installing and running the common, installing, adding a configuration file and then running the API, and then installing, adding a configuration file and then running the client. So it's a relatively sort of simple process. Of course, I mean, this is just a demo application. A lot of this configuration work could be done in the front end, but I think it's been a useful exercise it helped me certainly to understand a little bit better how the application's working and how IOTA works in terms of dealing with the the connection through the node providers and managing the wallets and things like that. Okay, so whilst that's installing, we can take a look at what we're going to have to do for the configuration file for the client. So this is located in demo client public data. So if we go in, you'll see here as we had previously. Now, if we just copy and paste and rename it again, as before, it just needs to be called local. local, yeah, config.local. And this one's actually, if I go into the one which is in my client here, copy that. And so with this one, it's a little bit easier to configure. It's really just it's showing the API that the client's connecting to. It's got the same nodes as the providers, and then we have some details here on the addresses that are used, which we'll come to this in a second. So I'm going to copy this so you can take what I'm going to put into the chat. Show. Where's the chat gone? Excuse me a second. Okay, so the code I've just copied into the chat is you can copy that into this config.local file with inside client public data. So it sits in here. And again, if you just save that, and then we'll be able to do the final step. So you'll notice here that I got an error when I was installing the client. That's fine. I was expecting that. You shouldn't receive the same error, hopefully, on your side. What I'm going to do is just, so once we've configured this, we just need to do npm run build. So you would go into to the client here and oh, excuse me, and you would do a Control C. You would do an npm run build. So just as we did with the API before, now you've got the configuration file saved. You just need to do npm run build. I won't do that because I've got it built already. And instead, I can just jump to the final step, which is to run the client over here. So I'm just going to do npm run build on the client, and so to confirm again, we've got the API running in the background, and now we have the client running in the front. So the client uses a React.js, for those people, for the developers who are interested. So this is the Facebook developed sort of JavaScript front end environment. So now we get, so this is just checking the time, we've got about 20 minutes, that's great. So we now have the full peer-to-peer energy grid up and running. It's running entirely on my machine. We can now sort of show you, it's very quick to sort of configure, to add the consumers and the sources and the producers to the grid. So if you should be able to type in as it shows you here, type in demonstration and click load. I've already got it loaded. So sorry, you click load as it shows there. So now what you see here is this is the sort of front end dashboard, which is going to show the consumption and production levels and give us access to see the data being passed across the channels in real time. So what we will do first is to actually configure the grid to add the entities that are participating. So we can add a producer. So we can just add a producer, and add a source, solar 1, and we just, if you recall before, we looked in the code, we could either select random or fixed in terms of the amount of production that's happening from the source. We just click, I'll just click random, and I'll just add one more source. So let's put in a wind powered source, and make it random again. And so we've got, and then if we just save that, click OK, and save. Okay, and it's coming back and saying the grid was successful. So what's happened here is that we've gone through that registration step that we showed in the documentation at the start. So via the API, it's registered the details, and it will have created the wallets to allow the producer to receive tokens. So we've got one producer. If we add a consumer, we'll add a couple of consumers, and we'll have them consuming energy randomly with the random amounts, and we'll click and add another consumer. So we've got two consumers, and we just save that, and it's confirmed back that it's been successfully updated. Okay. Okay, so it's initializing the data now against the grid. Whilst that's happening, we can just, what it does, it provides some useful information down here to tell you what the default parameters are for the consumption levels and the production levels. So it's sort of saying here that it only it sort of aggregates the data every 30 seconds. So you'll see the data start to flow after about 30 seconds after the grid's been set up. And then it gives you details about how the payments, what intervals the payments are made, etc. down there. So if we just have to sit and wait for it to start running. Hopefully we'll start to see some data coming through the grid. Now, in terms of how this works, so you can see a sort of aggregated log here of all of the messages that are happening. It tells you where the message is coming from. So you'll see here that the grid is, excuse me, it's rolling down quite quickly, but you've got messages coming in from the grid that it's receiving data, storing data, and I'm starting to see now flashing by usage information, which will be from the consumer and the level of usage. So all of these different messages here are the messages that we saw when we went through the instructions at the start, coming across all these different MAM channels. And now you see the data coming in from the sources. So the amount of energy that's being generated by the sources over the time intervals, and similarly the energy levels being consumed randomly by the consumers. They've got different consumption profiles here. You can also go and look at the specific MAM channels. So if I click on this here, unfortunately the IOTA guys have changed the addresses for these, so we just have to change that. Get rid of that. Streams. Let me check something. DevNet streams. Copy that. Okay. Yeah. So the start of the stream address has changed. So it'll always start. So what you effectively have here is you have this particular MAM channel. This code here is the root. So if you remember, we talked about when we set up a root for that wallet. The channel has a root. So this is the start of when the channel was established. So if we listen in through this Explorer to at this MAM channel, at this root, we then start to see all of the messages that are coming across that channel. So we first see that hello, which was the sort of initiation message. And then from that point onwards, we'll see the individual usage messages coming across at each step. And that will continue to just stream data for as long as the channel has been left open until it's deactivated. So I'm going to post the I'm going to post that the address that needs to be used into the chat again, so that you'll be able to see for your own local installs the data coming across. So this was a MAM usage channel, and then just to take a quick look, you also have if we change the start for this is the billing channel. So you get the messages here of there's a payment request, how much has been used, what's owed, and what the payment address is. So you can see that data flowing across as well. And then just reset this. Okay, yeah, you're starting to see data coming now. So inside the actual grid itself, we're starting to see data being summarized as to the accumulated running costs, the amount of IOTA tokens that have been received, which is 0 at the moment, so it hasn't caught up with payments yet, but the consumer, how much they paid out and what's outstanding, and the producers, how much they've received also. So we've got requested payments of 50 IOTA or MyOTA, and so I think we're just at the stage where the network is sort of catching up on those payments being passed across to the grid and then to the producers as well. So I think that's really everything that I had to cover. Just to kind of quickly summarize, then we've the instructions for the instructions for the peer-to-peer energy grid were posted in the chat. So we went through and explained how the network works, the entities that are involved, the importance of MAN channels, the second layer protocol, and then we went through the process of installing the code base, doing the configurations that we needed to get it to run locally with our own wallets to facilitate the payments. We've got the backend API running, and then we've also got the client, the front end running on React.js, and yeah, we're starting to see the data being flowing through the network. So I think that's really everything I had to cover. We've still got a few minutes. We're nearly running up against time, but I'll be happy to sort of take any questions from anyone. I'm going to stop sharing so I can jump to the chat to see. Okay.
I think one of the question was if the recording and everything that they need to run this offline will be available. I think the recording, I guess, yes.
Yes, yeah.
We can trim this part. eventually if whatever is better. So even my introduction, whatever is fine, I can skip through. And the other is about
sorry,
go
you
on.
go ahead.
Okay, yeah, and the other was about the instruction for the prerequisites. I think is on the GitHub page, but I think we can also share with all the participants, I guess. Again,
yes, is on the GitHub page, but there's also on the CBC website on the event entry. All the instructions are there as sent by Stephen. Yeah.
Just to
can keep the GitHub accessible, but I don't know how we're gonna manage with this second factor authentication now. I've seen somebody manage to bypass, which is also good, but a concern. I don't know how come. And third, I guess it's about the faucet was not working now. I've seen for somebody. We'll try that to get that sorted. But yeah, the main thing is that how we're gonna make them able to use to run through this again and do it after.
Yeah. So the just to clarify, the instructions that were in the invite, I think only cover they cover the prerequisites. But as Abel and Michele said, the full instructions are part of the GitHub repository, so they're actually here. Providing you get access to the repository to clone it, you can then click in and it's a PDF which runs through everything that I've run through today, including the prerequisites and all of the steps involved with configuring the API and the client and then getting it up and running. Once you've got the application working, to start the demo, you then just need to do npm run start on the API and then the same on the client. So once it's all installed and built, you've got to just run those two commands to get it up and running. And I provided a little bit of information on how to configure it at the end. So it's all in there. I think if it's okay, Michele, I'd recommend people who are interested in getting involved in this that they could sign up to the Discord channel for IOTA.
Yeah, sure.
Yeah.
Yeah, as I said, we can also keep access open for the GitHub, but I only worry that they will be asked for the PIN, and I don't know. They can also get in touch with me. Maybe we can create an account for those that are interested.
Okay, what I can suggest then, Michael and Stephen, is if people enjoyed today, and if there are like some, we need to go with certain caution in terms of distributing pins and so on. We can schedule another workshop in a few months and keep it recurring, because people will get familiarized with what we've done today. They will do their homework and they will learn more about it. And then eventually we can rerun the exercise and until we get the content. I also agree with the suggestion that access to the Discord channel could help quite a lot. And if you like, I can set up a Discord channel for CBC IOTA to keep things separate if you think this is more secure. But it's up to you.
Okay.
Yeah.
Yeah, I'd be keen to sort of come back and run through the progress we're making, because this is just the start. I mean, we've just got the. I'm really just standing up the code that IOTA have developed, but our plans are is to now take this code and adapt it so that we can connect in real energy sources into the grid. And one of the projects I'm working on is the concept of a sort of landlord of a shared residency is sort of monitoring the energy use for the particular flats within his complex. So it could be university accommodation, for example, and trying to incentivize and encourage people to be more energy conscious and to conserve energy. and if they're managing to reduce their energy consumption, they can be rewarded by receiving tokens automatically. So it'll be a sort of repurposing of this code to for a particular use case. So if people are sort of interested in that idea, then I'd be interested to come back and talk through what we've done to produce that. And if there's anyone out there who's a good developer that would be interested in participating, they could definitely contact me. I'd be happy to sort of get some people involved if they're interested in doing that.
So I'll just send you a very short poll now for people to respond if they want like a dedicated channel for IoT and blockchain. So guys, if everybody online, if you want to respond to that, then I can set this up, and then it can be like a channel for discussion for this particular type of discussion, because I think the whole IOTA initiative is just amazing what you can do with that. So Stephen, so maybe we could have something like that, and then we see when would be a good time to have a follow-up.
Yeah.
Awesome.
Okay, so it seems like 97% said yes. So I'll do. So
One person saying no.
Nobody who said no. Yeah, because
It wasn't,
it wasn't me either. So then I can set this up and then put it on the website. I think having that channel of discussion can kind of oil the wheels, if you like, Stephen.
Yeah.
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 Okay. So I'll close this now. I think everybody answered. Oh no. Okay. So I'll leave a little bit longer, open for a little bit longer. Okay.
April, shall we mention the RGU workshop?
Yes. Yeah. So I was just going to say thank you very much all who actually purchased a ticket during this workshop today for the next research workshop. We will be running this very soon. I think the dates, Leo, they are.
Yeah, just put it in the chat. Yeah.
Yeah. So they'll be very soon. For this you need, if you want to present, you can submit your abstract on the link in that Leo just sent. Let us know if you are a student or academic. We can try to facilitate as much as possible. And this will be a 2 days workshop. We'll be dealing with Solidity, which I believe will be available for IOTA as well at some point in the near future. It would be great to see you there. So I think it's all from my side, Mikhail and Stephen, if you want to conclude, I think, or if there is anything else you want to do.
No, just from me is to extend the offer if anybody out there wants to get involved in helping to sort of develop this solution out. We could potentially look to do it under the banner of the CBC. We're looking to sort of try and get this into some sort of production environment with some real clients to see whether or not this idea of a sort of a incentivized sort of energy tracking system, which facilitated people by paying them in tokens, whether this is something that is going to be useful to the so we're looking for sort of participants in that, and also to say that anybody, I put my LinkedIn up at the start, if anybody wants to contact me with any problems or issues related to this, then I'm happy to hear from them. Thanks.
Okay. Mikhail, any final words if people want to get more involved with IOTA?
Yeah, absolutely. Yeah, no, thanks for hosting this. it's definitely very, very good for us to get engaged with external community. If you have ideas on how to work, always go and look for the IOTA Ecosystem Development Fund. We're always looking for people to contribute with their expertise to some of our projects as open source technology. And the other, look for the documentation and get involved. You will get also my email probably. In case of anything, feel free to get in touch. And about the smart contract, just saying that I think there is also a collaboration. I'm not very good with their technology, but we are working with a partner called Cartesi that makes also our smart contract solution VM agnostic, so it can run basically on every VM that is already known for smart contracts, which is also good. And yeah, and Solidity is also in the roadmap on the other end to support contract written in Solidity in our network. So yeah, looking forward to this.
Fantastic. Okay. We definitely want to develop this branch of technology in the CBC and beyond. Everyone, if you just some final notes, Leo, let me know if I'm forgetting anything. Like, say, if you did not subscribe to the CBC mailing list, please do so, because then we can keep you posted. We send just very few emails occasionally. We don't spam at all, and just send news that are actually important. If you want to be more involved with the technology project that we'll be launching in the next few weeks, please let us know. Otherwise, I just want to thank everyone for turning up today, being part of it, and thank you very much, Mikhail and Stephen. Leo, anything we should say before?
That's it. Although, yeah, just to say, come to the RGU workshop. We'll see you there.
Yes. Stephen, thank you so much. And Mikhail, also, thank you very much. It was fantastic. I will be uploading the videos shortly once they are available. So they'll be linked on the website, on the CBC website, on the event page. And then you can watch again there.
Brilliant. Thank you.
Thanks, everybody. Thanks for your time.
Thanks very much.
Thank you. Thanks.
Bye-bye.
Thank you. Bye.